Okay, I guess I'll start. My name is Travis McIntosh. Welcome to the cameras of Uncharted 3. I was lead programmer on Uncharted 1, 2, and 3, and for all three of those games, I was kind of the point man on cameras. This is kind of a brain dump. This is kind of a post-mortem. This is everything I think is interesting about cameras, and I'm just going to give you everything I got. Okay. To start out, in case you haven't played Uncharted, this is kind of a feel for what kind of cameras we have in the game. We have a lot of different cameras. We kind of take a kitchen sink approach to gameplay. So we have aim cameras, we're a third-person shooter. We have a standard follow camera. We have spline cameras. We have designer cameras. I looked through the code. We have 31 programmer-written cameras. And that doesn't include all the different settings designers can tweak and all the things designers can do to our cameras. We also have animated cameras, Maya cameras. Basically, we have a lot of different cameras, and as opposed to making a few big cameras that are really smart about figuring out what to do, we decided to make a lot of small cameras, each of which does a very specific task, and then blend using our camera management system between cameras one at a time. So so you can kind of see the camera stack. I'll go over this in more detail later. But the bottom camera stack is kind of the programmer camera stack. That's what cameras are actually playing. So we went from a follow camera, which is our third-person camera, to an aim camera. Now we're on an edge camera, which is basically a third-person camera, but for edges. Now we're on a spline camera, which is a designer setup camera, kind of a fixed camera. Now we're back into the edge camera, and now this is an animated camera, so this camera comes out of Maya. So a lot of different cameras. I'm going to go over the major ones, not all 31, but the major ones that are interesting in this presentation. I'm going to start with something that our designers do a lot. This is the basic follow camera, the third-person camera. So we're in this little test level, but assume we're in a nice level and we have a big, pretty vista. So a designer has this vista and they want to show it off, but they want to leave the player in control. So this is a kind of tool, an in-game tool that we wrote for them. What you can kind of see here is a blue dot and a yellow dot on a kind of green line. The green line is our camera spline. It's a Bezier spline, and the smaller yellow dot is on another Bezier spline. So basically our camera has two splines. One is where the camera is, and one is where the yellow dot is. So this is kind of a 2D projection of the camera looking straight forward. So you have the camera, you have the target, and you kind of move the camera around the target. It's kind of to give you a feel for it. So in-game, you can kind of move, as you move the camera with the control stick, you can see the blue and yellow dots moving to give you a feel of what's going on with this camera. So I'm going to walk you through how we make this camera into a pretty vista camera for this location. So here you can use the mouse on the PS3 and kind of drag this camera around, kind of move it to wherever you want. So we want a big wide shot, so we're going to pull the camera way back wide. So at the close position, i.e. the bottom point and the top point, it's the same camera as it was, but all the points in between are very different. It's stretched out to kind of give a bigger view. So the target point, this yellow dot, is what the camera is looking at, and it's relative to Nathan Drake. So you can use these two splines to kind of create almost any angle you want. This kind of controls how you look up or down. So here you can see as I move this yellow dot, the camera isn't moving, but the thing the camera is looking at is moving. And it can move up or down, it can move in and out, give you a lot of control over basically whatever you want to do. When the designer's done with this camera, tweaking these settings, he exports it to our TTY, to the text output of our game, copies those settings into a script file or into our level editor, and then can turn on this camera at any point in the game he wants. And that gives him that's basically the interface. So this doesn't actually save directly to a camera. You have to actually cut and paste, but it's not a big deal. They don't mind too much. So now we're playing with our camera a lot, and so the last thing that we want to do to this camera is, right now you can see how the camera is very centered on Drake. So Drake is the center of the screen. That's not a very useful thing in combat. In combat, you do not want the center of the screen to be on Drake, because when you aim, you want the reticle to target what's behind the center of the screen. So if Drake is the center of the screen and you hit aim, you can't see what you're aiming at. So we have the ability to add a side offset to this camera. We can shift it right or left. So you can see here, we can shift it an extreme amount right or an extreme amount left. And in this case, this is not a combat camera. We just want a pretty vista. But this kind of gives it an artistic feel, puts Drake to one side, so it's also cool. So we're going to stretch it way to one side. And now we've set up our pretty camera. You can move it around, you can see the curve, and the designer would then turn this camera on when you got to the vista to kind of show off what's going on. A quick diversion to how our debugging for cameras works. So no player ever sees this, but it's very important for design, art, even programming to be able to play with the camera, to detach the camera from Drake and kind of move it around the world. We call it our manual camera because it's manually controlled. You're no longer controlling Drake. When you turn on the manual camera, you lose player control, so now you're just controlling the camera and not Drake. Drake's just hanging out. And then you can move the camera wherever you want, set it up however you feel like. Then you can go back into the menus and switch the joypad controls back to game, leaving the camera where it is. So now Drake can run around and you can see this camera, which is the real camera, the camera the player would see. And you can move it around with this normal controls while you run around Drake. This is really useful for debugging things, figuring out why the cameras are freaking out, what's going on, etc. And in Uncharted 3, for the first time, we introduced split screen. So in split screen, you need the same debugging features on both screens. So here we have the manual camera. Our menus expand when you go into split screen to supply two manual cameras, one for each side. We actually run different camera managers for each one. And also, you can use one controller, and we can go swap joypad screens. And that will swap the controller from controlling the upper left screen to controlling the lower right screen. So it's not a big deal. This seems really simple, but it's actually really important for workflow for people to be able to use the cameras. Another somewhat simple camera, but heavily used in Uncharted, is the animated camera. So this is a quick example from Uncharted 3. So a lot of times in Uncharted 3, we do these in-game cutscenes, and we have an animator animate a camera in Maya. So what's interesting about the way we do this is we actually embed the camera animation data in the animations for the characters. So Drake's animation has a separate channel which knows where his camera is, and Sully's as well, and anything animated knows where its camera is. So this makes it really simple for the designers to then, if they want to start a camera and they're already animating an object, just say, use whatever camera is available for this particular scene. And it also has some other advantages, which I'll go into later when I get to the melee section. So fixed cameras, very, very simple camera, the simplest we have. It's basically a camera in the world with an orientation, point orientation. That's not what I'm going to show you. I'm going to show you what our designers did with the fixed camera. So and Uncharted has a whole lot of parenting code. So we can parent cameras to things, we can parent Drake to things, we can parent things to other things, such as our train level, cruise ship level. In this case, one of our designers, Kurt Marganow, he parented a camera to an invisible object he set up, and then scripted this kind of helicopter camera for one of the desert scenes in Uncharted. So basically, he created a spline in our level editor, dropped it in, and then parented our camera to an invisible object which then moved along the spline. And all this code is written in script by one of our designers. He even had camera control by reading the stick and moving it back and forth. So it was a nice example of how flexible cameras can be if you give your designers the right tools. And I'm going to go over briefly how the designers actually implement cameras in Uncharted. So on the right, you can see a screenshot from our level editor called Charter. You can see kind of a trigger region and a couple cameras placed in Charter. On the left is the script code that our designers write. So there's a couple of simple script commands. The simplest is actually the second one, camera enable, camera 12, fixed, point 4. So what this means is turn on a camera named camera 12, and it's a fixed camera. That's the type of camera it is, and it blends in over 0.4 seconds. So this camera name comes from our level editor. So when you set up a camera in the level editor, you set up a name for it, and basically what this will do is it'll blend in over 0.4 seconds this camera. Another simple example is camera fade out, camera 12. So the same camera fades out over 0.2 seconds. Very trivial. Can be put on any trigger region, any script, any task, anything. More interesting is this camera abandon flag. So we use this a lot. This is kind of a weird concept to describe, but basically sometimes you want a camera to turn on, and you don't want it to go away until the player does something else. So you might want a camera like that Vista camera I showed you a couple slides back. You might want it to show a really neat Vista shot, and then if the player aims and you go into the aim camera, if you let go of the aim camera, you want to go back to a standard gameplay camera. You no longer want to show off this Vista shot. So what camera abandon does is says, okay, this camera is gone from the designer stack. The designers no longer want it, but don't get rid of the camera in real life until some other camera comes over and takes this over. The final example here is this camera enable self. So this is what I was talking about with the animated cameras. So when a designer has written some script, and he will often animate characters or objects. And if those characters or objects, say Drake, you play an animation on Drake, say Drake has a camera animation embedded in it, well, to enable that animated camera, you just say camera enable self, which means whatever my current state script has played animations, if any of those have camera animations, turn them on. And so it's a very simple way. There's not like a separate pipeline for getting the cameras in. The animators just put them in, the scenes they animate, and the designers just say, start it up. Okay, so very quickly I'll go over basically, this is the early example from the overview, but I want to focus on these camera stacks. So there are two. There's the top camera stack, and you can see at the very top, camera push wide follow cam 1. So it's right under the first dotted line. That's a designer camera, but it's a third person camera. So a designer has done what I showed you earlier with tweaking the camera settings, and then he has enabled that camera. So it has a designer priority of 13, but it is abandoned. So that means once you aim, it'll go away. On the bottom is the real cameras that are actually enabled. These are the programmer cameras. They're driven by the designer cameras, but they're not the designer cameras. And there are two enabled here. First is the manual base camera. So this is a weird camera. It's basically a last-ditch camera. If something goes wrong and we run out of all the other cameras get removed for some reason, which shouldn't usually happen, but if it does, we have something to tell the renderer where to render the game from. So it's this manual camera. In a typical game, the user will never see this camera. And on top is the follow camera, which is this designer-enabled camera. So now the player aims, and notice the abandoned camera is now gone. Now he's back into follow camera. So you can see here two numbers after the manual camera base. First is 1.0, and then 0.0. So 1.0 is how much the camera wants to be blended in. 0.0 is how much the camera actually is blended in. So it's a stack, so the bottom camera gets as much as it wants. So camera and edge wants to be 100%, so it is 100%. Here, the spline camera is blending in over top of the edge camera, and it is 19% blended in, which leaves 81% for the second camera. Note, when this edge camera is no longer contributing, when it's 0% contributing, it will be removed. So that camera is gone. We don't blend out cameras. We only blend them in. And then we remove cameras once they no longer affect the player's camera. So we always are blending in cameras over top. When we originally tried in Uncharted 1, we had blending in, blending out. But if you're blending out a camera underneath a camera you're blending in, you can get really weird kind of non-linear camera movements, which are not pretty. This is a quick side note. This is something pretty much everybody has to deal with if you give your player control with no player control cameras. So when you do a camera cut to show this pretty camera that the player isn't in control of, during the camera cut, if the player is holding down the stick, because our player controls are camera relative, the player would change directions. So you're holding down the stick forward because the camera's behind you. The camera cuts to the side. Now forward is no longer forward, it's left. And so Drake would change directions. So instead what we do is we say if the stick is being held down and we detect a camera cut, we just preserve the previous camera and do all the controls relative to the previous camera until the player lets go of the stick. So if you're holding forward and the camera cuts, Drake will continue walking in a straight line until you let go of the stick or turn it too much, like over a certain angle threshold. Spline cameras. So you've seen a couple examples of these in the overview and in that previous example. So what is a spline camera? So a spline camera is not a camera on a spline. This is a good example of a spline camera. We use these all the time in traversal when the designer wants a lot of control, not just putting the camera in one place, but having the camera move with Drake as he moves. So a spline camera is really, it's a set of fixed cameras. So each camera is fixed in space, tied together by a spline. So here's a third-person view, a debug view. So you can kind of see, here's Drake and here's the spline. So the spline defines where Drake can go, where the camera system cares about Drake. And you see these two white dots. So these two white dots each represent a different fixed camera, so a camera fixed in the world. And as Drake moves along the spline, the green dot is the point on the spline closest to Drake. So you can see here the green dot is 50% between control point 1 and control point 2. That means we just take the camera for control point 1 and the camera for control point 2, and we blend 50% between them. And we just adjust this as Drake moves with a couple of springs. So as you can see, this is really flexible. You can have a lot of different cameras attached to one spline, as many as you want, basically. And as you follow the spline, as Drake moves along the spline, the cameras will just go from your one camera to another camera to another camera. You can see the control points moving and the camera moving. This little green thing up top is the camera as it moves with Drake. And you can use these in one long line, or in Uncharted 2, we had these giant cylindrical things Drake had to climb around, and we would just do a looping spline camera around him, so as he climbed around, the spline camera would move with him, so it would kind of loop. Aiming camera. Aiming camera, pretty simple. There are some caveats, some tricky things to the way Uncharted does aiming. So in this simple case, you're just pulling the camera in. Center of the screen is maintained, no problems. Here's our cover camera. So for gameplay reasons, we want our cover camera to be significantly shifted out, so you can kind of see a big, much farther to the right. What that means is because the offset of the camera from Drake is changing significantly, and you can see here how much it shifts to the right. That means if we maintain the camera direction, the center of the screen will shift. So as a player, you never want the center of the screen to shift. If the center of the screen shifts, that means when I hit the aim button, what I wanted to aim at is now no longer what I'm actually going to aim at. So in order to solve this, we basically did a lot of math backwards and forwards for every camera, which is non-trivial because it means anytime I make a tweak to the follow camera, anytime I want to change how it works, I have to solve a geometric equation backwards so that I can present the camera with, basically what we want to be able to do is say, camera start, and make sure your center of the screen is right here, but preserve all the other things about you that make you an aim camera, i.e. you need to be the same offset away from Drake, you need to be able to rotate in any direction as you blend in, etc. In the future, I would love to change this, kind of solving my equations both way and just do a numerical solver that iterates over them, any camera, and produces the camera I want. In actual fact, we've already done this. We just didn't in Uncharted 1, 2, and 3. Here's another camera, a very strange camera from Uncharted 3. So we had some gameplay where we wanted the player to be able to hang on a ledge like this and shoot a guy standing on a platform above him. So we're in this view, and Drake wants to shoot a guy aiming down at him. That was really tricky, and the main reason was all of our cameras rotate around world space up, and this is a really good feeling for a player. This is what you typically want. In this case, if you're rotating around world space up, that means when you're aiming up, you're actually just rotating like this. And as an aim camera, you want, if I push the stick left, I want the reticle to move left. And if I push the stick right, I want the reticle to move right. So for a player, in order to feel like you're actually controlling the reticle, that's what you need. So that's what we did. But as you can see, it produces some kind of weird side effects. So when you're horizontal, you want the world space up to be the place you rotate around. But when you're vertical, you want it to be kind of sticking away from the wall. So you have to change the vector that the camera's rotating around as the player aims. And you can kind of see here, you get this rolling, twisting motion as Drake aims, which is a little disconcerting, but in playtests we found that it was actually very intuitive for players, because what they really care about in this section of gameplay is that the direction they push their reticle is the direction that the reticle moves. And so even though the roll kind of was weird, most of the time they were aiming straight up. And even when they wanted to aim straight up and then shift to straight left, it did what they wanted. It's kind of a lesser of all the evils. I couldn't come up with any math that would solve this in any different way. So it seems like the right solution to us. I'm going to briefly go over how we do camera collision in our third-person cameras. So as you can see here, we have a bunch of probes we do, kind of in a fan, that allow the camera to get pushed around corners. So you can see that they're tighter near the center, near where the camera currently is, and they kind of spread out as you go. So all we have to do then is, as Drake runs around the corner, if the center probe, the probe that tells us that we can see the player, hits, we just look at all the probes in the right side and the left side and pick the side that has the least number of actual collisions, and then shift the camera that direction. Note that this only happens, this pushing around corners only happens during non-combat gameplay. So when we first showed Uncharted 1 to the press, we got a lot of bad feedback. This is way back when we first showed it the first time. We got a lot of bad feedback about our camera systems. And it was because we had tried to do a lot of things to help the player. We wanted to show the player the enemies. So when you take cover, the camera would kind of shift to show you where the enemies are. Or when you did a roll or got shot, we would shift the camera to show you the direction. And people hated it. And the reason they hated it is because of the fact that we were moving the camera and they weren't. So anytime, our rule of thumb now is anytime the camera moves, it needs to be under player control. And that's because even if you get something so smart and so cool that 99% of the time it does the right thing and helps the player out, all they'll remember is the 1% of the time when they were going to shoot that guy and the camera shifted and screwed them up. And if, on the other hand, the camera's always under their control and then it messes up, they feel like it's their fault, and it's not frustrating. It's the game giving them control. So this kind of camera push movement in Uncharted only happens not when we're non-combat section. The combat camera only pulls in, never turns right or left. Okay, so the left side is for programmers, the right side is for designers. The left side is the differential equation for our camera smoothing. So all our cameras are kind of jerky. We figure out the ideal position of the camera, and we just put it there, which produces a lot of pops and bumps. So we smooth out the camera using this kind of spring system. So we have a camera target, ideal position, and the position of the camera last frame. We attach a spring to it and it kind of pulls the camera around. So it's not just a spring system, it is a damped spring system. So think of it like the shocks on your car. It's a spring, but it's also softened with a damper. So if you're a programmer, you might already know this equation, you might already know the solution. If you want to talk more about it, we can talk afterwards, but this is kind of a feel for it. What is important, however, about this equation is there's a factor, there's a damping factor and a spring constant. And if you adjust those, you get different curves. So what we want is a critically damped spring. That means to smooth out our cameras. So what is critically damped? So critically damped is the red line. That's the nice smooth curve that doesn't overshoot and approaches the target point in the fastest possible time. And then we have a couple other. If the damping is too loose, you kind of get this blue line, the big oscillating line, and that's going to cause your cameras to wobble back and forth. And if your factor is too tight, you'll get this light blue line up top, which does approach in a nice smooth way, but takes a really long time to get there. So you can solve the previous equation with a critically damped spring, which means it'll be this nice red line, so it'll perfectly approach what you're going to. And note that it's a differential equation, and it's very nice because it'll solve perfectly regardless of dt. So you can get like frame rate independent movement with this camera equation. So this is a smoother we don't just use for cameras. We use it for all sorts of things, but it's very important. It's kind of a final pass that we do on all our cameras. Okay, back to more pretty videos. Melee camera. So in Uncharted 3, we really we redid our melee system again. And one of our big goals was to have these kind of, you can see it there, kind of cinematic cut cameras that kind of go in and show you something pretty, something cinematic, and we wanted our animators to be able to make them, put them in at any point, but we also wanted the player to have control most of the time of the camera, and we also wanted that it never go through collision, it never do a jump cut, it never break the 180 rule. So a jump cut is a cut that's way too small, so it feels disconcerting. And breaking the 180 rule means if the Drake is on the left side of the screen and the guy he's fighting is on the right side, we never want that to flip. That's basic cinematography 101. If they flip, it's confusing, and the player feels like you feel like you lost your position in space. So it's really important to not break those rules and not go into collision. So what we did was, using the fact that we embed our camera data in the animations, what we did was we embedded multiple cameras in every melee animation. So Drake would have 4 or 5 different animated cameras for every melee move he had, or 2 or 3, or sometimes 1, but depended on our animators. And what we could do is, when we started a melee animation, we could analyze all those cameras and pick the one that fits the situation the best. We could run collision on the entire camera, we could check for jump cuts, we could make sure it didn't break the 180 rule, and pick the one we liked the most. And if none of them were available, like they all collided or there was no good one, then we stayed in normal camera mode like this. Note that if we knew we could cut a camera, we could also cut both characters. So we would pop both characters into new positions if the camera cut, and if the camera didn't cut, we'd blend them. So you would never see the pop because it was always covered by a camera cut, and if it wasn't covered by a camera cut, it wouldn't pop. So this is this again. This is it one more time. But this time I turned on debugging for camera collision. So you can kind of see these green lines, 1, 1, 1. So 1 means it's one camera, and each line is a frame of the animation. So what we could do is, because we have the entire camera animation embedded in the animation, we stepped through the animation before we played it and did raycasts from the target point, which is Drake's position, which is embedded in the animation, and the camera's position embedded in the animation. And we could run these raycasts with a one-frame delay and check if the camera was not just going to start in collision, but was ever going to be in collision during the entirety of the melee move, which allowed us to make informed decisions. So if you have a really huge sweeping camera that shows you pretty stuff, you can guarantee that it doesn't go through a wall halfway through. Because if you have cameras that turn on and off a lot, it's really disconcerting to the player. If you do a camera cut, you want it to take a while, to last quite a while. That's an example of when it didn't work. And you can see here, you have two different cameras, so the 0 and the 2. So that means the animator put 2 inside, and we got to pick between them which was which, and choose the one we liked the best. So, and just a note, so I was the point man on cameras, but there were a lot of programmers working on cameras on Uncharted, just like everybody works on everything at our company. So I did some of this, but this Melee camera is done by one of our programmers, Ian Jones, who did some really cool stuff with this. I just want to point out a couple people as we go, but there are tons of programmers at Naughty Dog who've invested a lot of time into our camera system. This is our cover camera. So there are a couple things to note about it. It's a fairly simple camera. When Drake's in cover, it kind of shifts the camera forward so you can kind of see around corners. Also note that as he switches directions here, left and right, we're actually not using one camera. It's actually two. It's a right cover camera and a left cover camera. They share code, but their settings are very different. And in our camera system, we can just blend seamlessly from one to the other, which is a lot simpler than every camera having to understand how to blend all its various factors in different ways. So we're just blending from one cover camera to the other. Another thing I want to mention here, specifically since this is a problem not only in the cover camera, but in a lot of different cameras, which is what do you do when the camera kind of pulls in too close? So the player wants to look backwards, but Drake has his back against this wall. So I can't put the camera low because it'll clip through Drake's head. And some games solve this with like fading out the player, kind of having an outline. We didn't really like that solution because it looks a little gamey at times, and we really, in Uncharted, want to keep the player grounded in the game world. So instead, we just pull the camera up. We do this not just in the cover camera, but in all the follow cameras. So we pull the camera up above his head, kind of go, you could think of it as a first-person view almost, because Drake is off screen, which kind of makes the player lose where Drake is sometimes, but it's kind of another lesser of multiple evils, and this was our favorite solution. Moving platforms. So everything moves in Uncharted. Trains, ships, boats, every level. I think there were like 2 levels in Uncharted 3 that didn't move. So this one is one of the simpler examples from the camera's perspective. So there are a bunch of moving platforms in this rolling ocean. So Drake is on the platform, and he's parented to it, so he moves with it. And the camera is parented to Drake, so the camera moves with Drake. So the camera's position is moving up and down with Drake. So from the camera's perspective, it looks like Drake isn't moving. However, one thing that's different about the cameras and other things that parent is in a lot of cases, though not all, we want the camera to parent position, but not necessarily rotation, because it's important to make the player feel like he's on a rolling platform. If we completely parent Drake, completely do the platform, makes it feel like the world isn't moving at all, which is kind of the point of the whole level, so it's kind of a waste of our time. So the camera will rotate back and forth as the platform rotates, but the position always stays with Drake. Here's a more complicated example. This is the cruise ship level, by far the hardest level I've ever worked on in my entire life. The cruise ship level actually moves so much that we didn't want the camera to show how much it was moving all the time. So you can see here, it's moving too much. We still wanted the camera to roll as the ship rolled. And you can kind of see here how the camera is moving with Drake as the ship rolls around the ocean. But when we first put it in, the camera moved so much, everyone, even we, got very nauseous, seasick from the game. So we put in this moving platform blend percentage. You can see here, I just tweaked it from 50% to 0. So what this does is it blends the camera between 2 spaces. One is rolling with, the camera is in the world and the ship rolls under it, and the other is the camera is parented to the ship. And so it feels like the ship isn't moving at all. So this factor is not always 50%. We actually gave the designers full control over this factor as they moved through the world of the cruise ship. I don't think they used it too often anywhere else. what's interesting to note is sometimes in the cruise ship, the world would be moving, and they would set it completely to 1.0 like this. So you would feel like the world isn't moving. So in Uncharted 1, we used camera rotation to fake the fact that the ship was, that our little boat was not rolling in the ocean. In Uncharted 3, we used the camera to fake the fact that the ship was moving to make it feel like it wasn't. You can see here how all this control was useful for our designers as they go in and out of interior spaces and exterior spaces throughout the cruise ship. And just to show you how much the cruise ship is actually moving in the world. It's not a little. It's going up maybe 40, 50 of our game meters as you play on it the entire time. Okay? Another kind of tricky thing in Uncharted 3, which we never did before, was we wanted the player to be able to swim in choppy water, and really choppy water, as you can see here. We'd always had him swim on like still ponds before. So ignoring the fact that it was complicated to get Drake to swim on it, the camera had a bigger problem, which is we couldn't use standard camera collision because A, the water isn't real collision, it's water, and B, if we did use normal camera collision, whenever a big wave came up, camera collision typically pulls the camera in. So the camera would pull in on Drake and kind of in a choppy back and forth way, which wasn't fun at all. So instead what we did was we used water probes, which we could figure out the height of the water, and we just offset the camera by those water probes. So we would let the camera run like normal, completely to the end, and then as a final pass in the camera manager, we would do water probes. And you can see here this little gray camera on the bottom, that's where the camera thinks it should be based on standard camera stuff. And the colored camera is where it gets offset to by the water probes. And that allows this camera to function without ever clipping the water. Anytime it clips the water, it's going to look bad. So it never clips the water in Uncharted 3. It just kind of shifts up and down with it. And this gave us a really good camera for this water sequence. And give me 1 second, I'll show you. Yeah, here we go. This is what it kind of looked like while you were playing the game. So you can see the camera is pretty much guaranteed never to go through the water, no matter what crazy things the waves do. So starting in Uncharted 1, we wanted a handheld camera. We wanted the camera to feel like it was shaking and like it was going to be so cool. And we failed on Uncharted 1 and 2 to really come up with anything anybody in the company liked. And on Uncharted 3, we finally got something we kind of like. And basically, our problems in Uncharted 1 and 2, the number one problem was we kept thinking of a handheld camera as from a movie camera. So in a movie camera, you want the handheld to like jitter and jiggle and bounce as you follow the player through. In a game, when you have high-frequency movement like this, what you get is instead, you get the camera, people think the camera is buggy, or they think the frame rate is low. So instead, and you can see here an example, we did really low-frequency movement, so kind of like huge impacts as he lands. And you can see I'm going to go do that again without the camera shake in, so you can kind of feel the difference. So the camera shake, we implemented it this way. Now, we originally, in Uncharted 1 and 2, were always trying to come up with systems. We wanted programmers to be able to implement like some sort of spring, and we'll pretend like it's a cameraman, and we'll move him left and right, and we'll do all this really neat, fancy stuff. And we never got it right. So instead what we did in Uncharted 3 was we gave the total control to the animators. So you can see here, this is script code written by our animators. And on the left are player animations. So these are all different animations Drake plays. And then this :anim is going to name a camera additive animation. So this is a camera animation that's just like a delta. It's usually a delta rotation. We support position movement, but we don't support collision with position movement. So anytime they move the camera, it might go through a wall. So typically, they don't do any movement on the cameras, just rotation. And you could, as you saw, slow rotations. So they can tie it to a frame. That means when Drake is on tense idle to run 180R, on frame 2, we start this camera animation, and it's 10% of this camera animation. And you could have multiple of these camera animations on different frames for each Drake animation, and they can extend past the animation or get cut off. And this was all done by our animators. Once this was written, we didn't help them at all. They just took it from us, and it was really nice. Okay, I'm approaching the end here, so I'm going to go over 3D. So 3D was a big deal. This was the first time we ever did 3D in Uncharted. And what's interesting about the way we did 3D is we actually rendered the entire game twice, one for each eye, which gives you the best, most correct 3D. A lot of people do the depth buffer trick, which works, but we decided to go all the way. So this is a quick 3D primer. So you can see the left eye and the right eye are your two cameras. There are two values in 3D that are 3D settings that matter for our game. So one is the distortion, and that's the distance between the eyes. So it's the distance between the two camera eyes is the distortion. And the other is called the zero plane distance. So this is kind of where the two cameras intersect. And what's important about this is if something is at the zero plane distance, that means it's exactly on the screen. It's neither behind the screen or in front of the screen. So if you take off your 3D glasses, something on the zero plane will be in focus completely. So the zero plane was very important to us, and I'll go over why. So quick 3D primer. Here's everything we learned about 3D in Uncharted. The distortion we never changed. Anytime we changed the distortion, if we animated it, if we cut it, if we changed it between levels, it was really disconcerting to players. They would feel, their eyes would feel bad, it would give them headaches, it was confusing. Your eyes don't like to change focus distance a lot, and that's what the distortion really affects most. Well, the only time you could edit distortion was in the user options, where you could change the 3D slider, and that's what the 3D slider did. It adjusted the distance between the cameras. We also, originally, we had all these plans. We were going to give the designers control of these 3D settings for every single camera they set up. We were going to give the animators control for every single shot they animated between cuts. And when people did use it, it was horrible. It was really confusing because again, the 3D settings would shift between shots, and your eyes would go out of focus, or there would be problems with kind of miniaturization. Things would look miniature because they wanted to change these different values. So at the end of the game, we just stripped it all out and did a couple of things, which I'm going to go over in a second, that were just procedural and worked the entire game and fixed 99% of our 3D bugs. Another thing to be very careful of is heavy depth of field, which we use a lot in Uncharted. We had to dial back kind of like across the board for the 3D game. Because 3D gives you so much feeling for how far away something is. If something close has a depth of field, it looks like a blurry texture. It doesn't look like depth of field anymore. So it was a big deal to reduce the depth of field. Also, animating the FOV in 3D will make you sick. It is horrible. So we kind of tried to really stay away from animating big FOV changes, the kind of like pullback stuff. One of our big goals about 3D was we didn't want people play a 3D game a lot longer than they watch a 3D movie. And so it's really important to kind of minimize these kind of headache-inducing 3D effects. So it was a big deal for us. We also never let anything come out of the screen. So in movie theaters, they do this all the time. They stick things out of the screen into your face, which is kind of fun and gimmicky, but in a game is not a 3D. You're watching on a small TV usually, very close to your eyes, so when things stick out, you basically have to cross your eyes, which is one of the things that causes headaches. So we only push things into the screen in Uncharted, always. And this last one is not something you can probably control, but it is just a note. High contrast scenes where you have brights next to darks. In 3D, most 3D TVs, in fact, everyone we found and tried, had what we call ghosting, which is the right eye would see a part of the frame for the left eye or vice versa, and what it looks like is kind of double vision when you're watching a 3D, and that happened in big high contrast areas. And this is not something the hardware is doing wrong, it's something the TV is doing wrong, and there just aren't the TV technology is just not quite there to completely eliminate it. So if you have high contrast scenes, you'll get some ghosting. It wasn't that bad, but it's notable. So what did we do to solve our 3D bugs? So the one of the things was we put the zero plane where the player is. So if the camera was far back from the player, we put the zero plane on him. If he was close up, we put the zero plane on him. That's because you're always looking at Drake the whole game pretty much. And so we kept him in focus, basically. So if you took off your 3D glasses, Drake was perfectly in focus in 99% of Uncharted 3. We also put in a lot of safeguards to prevent distortions. So if there's like a one-frame pop in their normal game, maybe it's kind of annoying. Maybe you notice it, but not too much. If it's in 3D, your eyes go out of focus. It's really bad. So we put in the safeguards. And the safeguard we put in, and this is the #1 best thing we did, was we read the Z buffer every frame and found the closest point to the camera. So whatever closest point that was based on the Z buffer, and then we made sure the zero plane was at least that close. So that guaranteed that it was impossible for anything to ever come out of the screen for any reason. And originally we had a lot of problems with, so we had the zero plane at Drake, and then something would collapse behind him and a rock would fall between the camera and the player. And it would be for 2 frames, there would be this big rock in your face, jutting out of the screen. It would throw your eyes off, it would hurt, it would be confusing. With the zero plane pulling in based on the Z buffer, the rock would suddenly become in focus. And if you think about it, what that means is your eyes are focusing on the plane of the screen because you're looking at Drake. Then the rock comes in between you and Drake. The zero plane is moved up to the rock, and now your eyes are still focusing on the plane of the screen. So your eyes don't have to adjust when that happens. And it really helped make 3D not near as painful as it otherwise would have been. A few thanks. I want to thank Jason Gregory, who helped me with the slides here, all the designers and programmers who worked on all of this stuff, and then I'm going to throw it open to questions. And a couple shameless plugs for other Uncharted talks coming up.
Hello. I just have a quick question on one of your last points. When you moved the zero plane, did you blend it or did you pop it?
Popped it. So the question was, when I moved the zero plane in, did I blend it slowly over time or pop it? I just took the closest point and set it every frame straight up, and it was not noticeable at all. Go ahead.
Hey, your last slide, it looked like you directed the cameras by your stereoscopic cameras by actually like towing in the 2 cameras. Is that how you set it up, or?
That's basically how 3D works. That's how you get the zero plane, is by tilting in the cameras so that they kind of intersect at where the zero plane is, and then the distance between the cameras is the distortion point.
Okay, there's another method in which uses parallel projection, where you're actually modifying the planes of the frustum. Did you look into that at all? Because one of the problems that you have with actually using 2 cameras and towing them in is that you get distortion on the edges of the frustum.
We tried a bunch of different things. This seemed to work for us.
Okay.
I really love the general approach of having simpler cameras and having a complex blend, like weighted blend stack. I think that's really clever. How do you handle, I know in the combat scene you were doing hard cuts, but when you're doing smooth blends between valid cameras, how do you ensure the validity of the interpolation between things, because that's sort of ungoverned, you know?
Yes, basically, and this is something I'd like to do in the future. The question was, how do we deal with the validity of the middle camera position if you're blending from one camera to the other? And basically, we don't. 90% of the time, it's fine, and a few times when it's, and basically, we go through collisions sometimes, basically, and this will happen anywhere, and we typically, our designers kind of tweak the cameras to try and prevent it from happening, and sometimes it happens anyways. I would like in the future to actually put a final camera collision pass, but I haven't done it yet.
And then related to that, with the sort of walking through the camera information that's embedded in the animation for the combat stuff, doing a predictive like trace, do you do that in any of the other cameras or any of the other situations where you're trying to predict
So the question was doing the predictive trace for the camera animations in the melee combat. Do we do that anywhere else? We actually did in Uncharted, one of the early chase scenes. We would have people grab Drake, catch him as he was running, and we used basically the exact same code to do predictive camera traces, but it was only for animated cameras because otherwise the thing about animated cameras is we actually have all the information about where the camera is going to be for the entirety of the animation. So we can do the predictive camera trace. If it's a more procedural camera, it's a lot harder to figure that stuff out.
Hi, quick first question. Will these slides be available?
They should be. I think all of the slides will be available. I'll try to make sure they are.
Okay, and so when you talked about dealing with collisions and you mentioned that you just pull the camera in, did you have to deal with, or if you did with any clipping when Drake was going around corners, how did you address that issue?
When we pulled the camera in on Drake, if we don't rotate the camera and Drake runs past the corner and we pull it in on him. So is that the question?
Well, the question, for instance, if Drake is running over here, let's say this is a corner and there's a wall over here, and he suddenly turns left and go that way, the camera should be, I would imagine that it would be falling this way, and then suddenly it has to traverse through that way, but then it's likely going to either clip around the corner or go through the wall. How do you get it to go around it?
So what we typically did, so in combat we don't rotate the camera at all. So if Drake runs forward and then takes a tight corner, the camera has to pull in to maintain the camera direction. It's very important for combat that the camera direction be maintained. So we would just, so we did two things. One, we would pull the camera in very quickly, and sometimes it can theoretically clip. In practice, it typically doesn't. But the other thing we did is when we pull in close to Drake, the camera shifts up, kind of above his head. So we're both pulling in and up at the same time. And we have much tighter springs when you run in combat than we do in kind of normal third-person mode. So the tighter springs pulls the camera in faster, and it just mostly works.
So you never had to tell the camera never had to push it to the opposite side to go away from the wall?
No, we don't. We won't push the camera in combat because it's just like you're looking. There's a guy over there you want to shoot. You're running towards him, and then you decide to run right. If we push the camera in any direction, you've lost your aim on the guy, and it's really frustrating for the player. So we never do that. We always maintain the direction the player wants.
And my last question is about the probes that you have around the player. Do you assign weights to them in order because you're talking about you have those several probes around, and you mentioned that you would put the camera on the opposite side of the collision. Did I get that part right?
Basically what we do the probes in kind of a wedge, and then we start here, and if there's a collision, we examine all the probes all the way down the wedge and kind of weight the ones towards the center higher and figure out, basically we're trying to figure out a direction to go. We don't necessarily go straight to one of the probes, but we want to know which direction to turn. And so we can kind of examine all the probes in both sides, see where they hit, which is closer in, and kind of weight them all, come up with some factors, and decide a direction to go.
Thank you.
Sure.
Hi. So my question was when you were talking about the 3D and you were talking about where the camera is like the zero plane, is how does the UI work when you were doing it in 3D? Because like the UI is always kind of important. Is what
the UI had its own camera and its own like 3D camera, so it was in a different. The UI was kind of in a different. It used the same kind of distortion value, but the zero plane was not the same zero plane for the UI. So.
Gotcha. Thank you.
So it seems like your camera system is doing a fair amount of processing, especially with the predictive traces on the animated cameras and whatnot. Were you able to push much of that to the SPUs, or was it all done on PU?
Yes, all the collision probes that I showed you up here, including the raycasting trace, were basically one frame delayed. So we would kick all the, okay, let me take that back. So some of them, the probes in the follow camera, we kicked them early in the frame and gathered them later. And then the long raycast probes, we actually did the frame before because we knew you were about to go into a melee camera. So we would do the probes, kick all the raycasts, and then the next frame, gather the results, and then deal with them. So we never waited on SPUs. We did a lot of it on the SPUs.
Can you comment on any performance trade-offs you had to make to render the scene twice in 3D?
Yeah, it was. So there are a lot of problems with that. I could give a whole talk on how complicated that was. Suffice to say, we did some resolution tricks to reduce the pixels. We had to do split screen anyways, so we had to solve a lot of these problems. We actually had objects would be marked as don't render in 3D. We went over like all the levels in the game to deal with that, and we had a lot of SPU problems because we do a lot of rendering work on the SPUs, so we had to do it twice. The frame rate is slightly lower, but pretty good in 3D, and it took, let's just say it was a lot of work.
Hello, I have more of an organizational question. With some cameras defined by animators, some other cameras defined by designers, how you maintain the cinematic presentation homogeneous? Was there any cinematic director advising or supervising the whole process?
So the question was, like, how do we manage making sure we have all these nice cinematic cameras that seamlessly blend? So the typical way we set this stuff up is a designer will set up his level, and then he will sit down with an animator, and they will say, okay, so we want this scene to play out this way. If it's an in-game cutscene like that, they'll sit down with the game director or the writers and kind of figure out kind of what they want, and then all those people, 2 or 3 or 4, will go together and just do it and then iterate on it. So we have a lot of people just sitting down together in a room, just doing it over and over until it looks good. And there is, of course, we do have a game director who has kind of the full vision for the game, and he will be somewhat involved or heavily involved depending on how important it is. So the vision is held by one guy, but each designer is responsible for their kind of level and that sort of thing.
So no cinematic cameraman, but more of an animator meets designer.
We have some animators who are very cinematic, I guess, like the lead animator or the cinematics animator would be. They do lots of different things, but they also do that. And some of our designers are really cinematic. So it's kind of like everybody has their say.
Many things.
Sure.
So when working with when transitioning between 2 different cameras that have different offsets, you mentioned that you had to, solve and find out where the player was aiming so that the aim position doesn't move. But in doing that, you have to assume some focal length. How did you define what the distance was that the player was aiming towards? So we actually did the question is, how do we know where the player is actually aiming when we switch between 2 aiming cameras? So it's actually not a focal length, it's actually a collision probe that comes out of the camera, again, an asynchronous collision probe done every frame. So we always know the actual collision position of what is under the reticle. So whenever we need to know, okay, where's the center of the screen in 3D space, we would just use that collision probe and it would tell us, oh, it's right here in this position. Yeah, and actually, something I didn't mention, but sometimes it would be too close to the screen. So Drake is up against a wall and he hits the aim button, but it's a big flat wall. You don't want to, in that case, in order to maintain the center of the screen, you actually have to shift the camera way to the side, which is really confusing for a player. So we actually have kind of like the center of the screen has to be at least a certain distance out. And if it is too close, we just maintain the camera direction instead of the center of the screen. All right, and then my other question is, on every project I've ever been on, the camera is like the little redheaded stepchild of a system that nobody wants to own. How do you think it was it sounds like you guys put a lot of time into your cameras. So it's like the exact opposite of what I usually see. Like, how do I convince everybody to actually put real time into our cameras?
Yeah, I don't know how to convince designers. Every designer I've worked with is very interested in the cameras.
Yeah, I'm a designer.
Okay, there you go. And I don't know. I've always liked cameras myself, so I thought it was really interesting. I think one reason our cameras are more fun for us to write is because we have this kind of modular system. Like, there aren't Uber cameras. I found that in the past at other studios, there was one giant camera that does everything, and it becomes a mess. And as a programmer, the worst thing to do is work on somebody else's messy code. Whereas with our camera system, if we want a new camera, you write your own camera, and it's very small and compact, and utilizes a few systems we have, and then you just blend that in as a new camera. And because it's so modular, it's easier to work on. Like I said, I was not the only programmer to write cameras. Half the programmers on our team wrote cameras, and they all wrote it for the system they were working on. The Melee camera was written by the Melee guy, and the AIM camera was written by the Gunplay people, and et cetera, et cetera. So that tends to work for us. I don't know.
All right, thanks.
Sure. Okay, thank you very much.